We'll now examine the selective repeat ARQ protocol. So this error and flow control mechanism operates at the data link layer. So this is an elementary data link layer protocol. In contrast to go back N, which retransmit all packets from the point of failure, selective repeat enhances efficiency by retransmitting only the specific packet that was lost or corrupted. This approach minimizes redundant transmissions and is particularly beneficial in high bandwidth, high latency networks. So like in go back N, we have two components. One is the sender and second is the receiver. The sender maintains a sliding window of packets. Here we assume a sliding window of size 4. Each packet sent is associated with an individual timer. Upon receiving a packet's acknowledgement, the sender marks the packet as successfully received. If a timer expires before the acknowledgement is received, the sender assumes the corresponding packet was lost and initiates a retransmission for that specific packet alone. The receiver also uses a sliding window to keep track of the next expected sequence number. When an in order packet arrives, the receiver accepts it and sends an individual acknowledgement. If an out of order packet arrives, the receiver does not discard it. Instead, it stores the packet in a temporary receiver buffer. This buffered packet is held until its preceding packets are received, at which point the entire sequence of in-order packets can be delivered to the application layer. So let us observe a typical packet loss scenario as the visualizer executes. The sender initiates communication by transmitting a sequence of packets within its window, beginning with P0. We observe the blue packet representations moving from the sender to the receiver. A timer is activated for each packet upon transmission. The next available sequence number is now 4. As packets traverse the channel, packet 1 is intentionally dropped. It will vanish from the screen, simulating a loss in transit. The sender's timer for P1, however, continues to run, unaware of this loss. Out of order packets arrive. The receiver now accepts P0 as it is the next expected packet. It is immediately delivered and an acknowledgement for P0 is sent back. As P2 and P3 arrive out of order, instead of being discarded, they are buffered by the receiver. This is an important feature of this protocol. You will see these packets appear in the dedicated receiver buffer area. The receiver sends individual acknowledgements for both P2 and P3, informing the sender that these packets have been received and buffered. Upon receiving the acknowledgements for P2 and P3, the sender knows that these packets are safe, but since its window has not advanced, it cannot yet deliver them to the application layer. It continues transmitting the subsequent packets P4 through P7. The sender's timer for P1 expires. The sender interprets this as a definitive loss of the packet and will retransmit it. In response to the timeout, the sender retransmits only P1. The subsequent packets which are successfully delivered will not be retransmitted. Once P1 is successfully received, then receiver acknowledges P1. The receiver sends a final acknowledgement for the entire in-order sequence, confirming successful reception. The sender's window slides to encompass the next set of unacknowledged packets. With all packets now delivered and acknowledged, the simulation concludes. Selective repeats. Selective repeat provides a more resilient and efficient method for data transmission by selectively retransmitting only the data packet that is lost. Thank you.